Hi, I'm Vicki Murley, the Safari Technologies Evangelist at Apple. Developing a mobile application is not the same as developing an application for the desktop. Unlike a traditional desktop system, a mobile device has tight memory constraints, probably uses flash memory, and it depends on great battery life. iPhone has a number of design features that address these differences, including specialized hardware components that are turned off when they're not being used. But your practices as a developer significantly affect the device's performance as well. In order to develop a great application for iPhone, you really have to abandon a lot of your typical desktop conventions in favor of a truly mobile mindset. Besides the guiding practices that might apply to any mobile application, there are also additional iPhone-specific issues that you need to be aware of during your application development. In this video, I'm going to cover what mobility means for your development in terms of 5 topics. First, I'm going to talk about the design of your application. If you're new to mobile development, there are some common pitfalls that you can avoid just by thinking things through in the design phase of your development. After that, I'll talk about one of the restricted aspects of development on most mobile platforms, including iPhone, and that's memory. I'll tell you what you can do to reduce your application's memory footprint and what it means to be a good citizen on iPhone in terms of memory. Next, I'll go over how to ensure great responsiveness on iPhone. After that, I'll discuss power and what you can do to minimize power consumption in your application. And finally, I'll talk about security and what restrictions you need to be aware of for your application on iPhone. So let's get started with design. I want to touch on design briefly in the context of best practices because on iPhone, decisions that you make during the design phase will have a big impact on your application's performance. When you're designing an application for iPhone, it's important to remember that mobile devices like iPhone present an entirely new interaction paradigm for your users. Unlike a desktop environment where users may use your application for many minutes, hours, or even days, on iPhone, users, for the most part, may only interact with your application for a few seconds. Most of your users will pull their iPhone out of their pocket, quickly use it, and then quickly put it away. When you think about this kind of usage pattern, it's easy to realize that you really have to present information quickly as soon as your application is launched. When you're deciding how to present this information, keep in mind that you have limited screen real estate on iPhone when compared to most desktop systems. On a desktop display, you might have a resolution of 1024 by 768 pixels, giving you almost 800,000 pixels of real estate to work with. And that's probably the smallest resolution that you'd be working with. The resolution on a 30-inch display is typically 2560 by 1600 pixels. On iPhone, the story is totally different. Even though 480 by 320 is a high resolution for mobile devices, it's significantly less real estate than you would have on a desktop display. So what can you do about this? And how should you think about this when you're developing an application for a device like iPhone? The answer is really to keep your user interface simple, uncluttered, and well organized. Keeping it simple in your application in terms of design and purpose is really the first step in creating an application that is light, efficient, and zippy on iPhone. Also, remember that your application should address a specific need. Most of the built-in applications do one thing very, very well, instead of trying to do many things only moderately well. The built-in phone application is great for making phone calls. The mail application gets you to your messages quickly. The iPod application is an excellent portal to your music collection. And the Maps application does a great job telling you where you are, where you want to be, and how to get there. Logistically, there's one more thing to keep in mind during the design phase of your application, and that's that there's no background or suspended applications on iPhone. So unlike modern desktop operating systems on which you can run many applications at once, many in the background, one in the foreground, on iPhone, pushing the home button terminates your application. If you have code that launches another application, this also causes your application to quit. I'll talk more later about what specifically you should do when your application quits to be a good citizen on iPhone and how to create a good experience for your users. But for now, just remember to keep this in mind when you're thinking about your application design. So once you've thought through the design of your application in terms of performance, it's time to start coding, which means it's time to start thinking about memory. The first thing that you need to know about memory on iPhone is that virtual memory is constrained by physical memory. There is no swap file. Once the available memory on the device is used up, iPhone will reboot. This is probably not the user experience that you're aiming for with your application. Luckily, there's some built-in help on the system to help you keep the memory footprint for your application nice and small. And I have a few additional pieces of advice that you can follow for your application to minimize its memory footprint. First, let's talk about the built-in help that's provided. When you use the standard iPhone template and build your application for deployment with Xcode, there are 3 things that are done for you automatically. First, all of the ping images that you use in your UI are optimized. They're compressed, and their makeup, but not their appearance, is altered slightly to work better with iPhone. For this reason, ping is the recommended image format for iPhone. Second, property lists, orplists, which are the files that your application uses to store preferences or other information, are all converted to binary format. Lastly, your application will be built by default using the thumb instruction set. Now, the thumb instruction set features a subset of the most commonly used 32-bit ARM instructions, which have been compressed into 16-bit wide operation codes. Upon execution, these 16-bit instructions are decoded to enable the same functions as their full 32-bit ARM instruction equivalents. This approach yields about a 35% reduction in code size when compared to ARM. There's only one caveat, and that is, since thumb is a subset of the ARM instruction set, sometimes more 16-bit thumb instructions are needed to accomplish the same overall function. Floating point operations, for example, require more instructions to execute in thumb than they do in ARM. Although the difference in performance here is pretty small and won't be noticeable to almost all developers, if you have code that is seriously floating point intensive, you might consider building your project both ARM and thumb. Then look at the performance and code size for your application with each instruction set and weigh the benefits of each. If you think that thumb might be a concern for you, really the only way to know for sure is to test your application. So the first thing that you should do is ensure that your application has 0 leaks. When you're checking for leaks or doing any kind of performance testing, it's always good to take a methodical approach. Begin by identifying all the scenarios that a user might run through for your application, and then prioritize them from the most to least common. Start at the beginning and run through each of these scenarios one by one, and at the end of each, check for leaks. By breaking down all your operations into discrete subsets and testing each of these at regular intervals during development, you're going to ensure that you're writing clean, leak-free code as you go. Building this critical performance work into your development cycle is a much better approach than saving it until the very end, when you're trying to fix those last few stubborn bugs or trying to squeeze in a must-have feature. Although the simulator doesn't use the full iPhone operating system stack, you can check for leaks in your code in this environment. However, if possible, you should always use instruments to attach to your application and check for leaks running on real hardware. In a mobile environment like the one on iPhone, a leaky application will lead to a sluggish and unresponsive system. Make sure that your users have a positive experience by ensuring that the leak count is 0 before you ship. Another thing you should do is release memory as soon as possible. Besides manually releasing objects when you can, another good approach is to bracket the memory-intensive routines in your code with auto-release pools. Doing so would look something like what you see here. At the beginning of your method, modify my string, you create an auto-release pool, and at the end, you release this pool. With this approach, you won't have to worry about which objects from system frameworks are marked as auto-release, and you will free up memory more quickly than if you waited for the system to take care of it. Another valuable memory tip is to memory map or mmap files whenever possible. Although virtual memory is not available on iPhone, files can be mapped into memory, which means you can manage large files as needed yourself. There is a trade-off. You have to write additional code to manage this memory, but it's up to you to decide whether the benefits are worth it. You can also minimize your memory footprint by being prudent with memory. One way to do this is to always load resources lazily in your application. For example, when I launch Mail and visit my inbox, only the first few lines of the message are loaded and displayed. The entire message and any attachments are only loaded once I decide to view the contents of that message. You can also choose to impose resource and display limits in your application to avoid a large memory footprint. Again, the built-in Mail application on iPhone has a great example of this practice. When I visit my inbox, my entire inbox isn't loaded. Only the first 25 messages are loaded. For me, this is usually sufficient, but if it's not, I have the option of loading 25 more. So you're using the built-in tools in Xcode, your application doesn't have any leaks, and you've gone through every possible memory optimization that you can think of. What else is there? Well, on iPhone, in order to be a good citizen in terms of memory, you should also observe low memory warnings. When available memory becomes low on iPhone, a warning is sent out to all applications, including the built-in applications from Apple. No one is exempt. When this happens, all applications should try to free up memory. There are 3 ways that your application can receive low memory warnings, and they're all available in UIKit. First, you can implement the application did receive memory warning method of your application delegate, or you could override the did receive memory warning method in your custom UI view controller subclass, or you can register to receive the UI application did receive memory warning notification. When your application receives a low memory warning, you should try to free up as much memory as possible. Of course, each application is unique, but some of the possibilities for freeing up memory include purging off-screen views. For example, in Safari on iPhone, I might want to close any tab views that are off-screen. You can also empty any caches in your application, and lastly, you can clear any cached image data. When all of the applications on iPhone, including your application, work together to improve memory availability, this results in a better experience for your user, and everyone benefits. Now that we've covered memory, let's move on to responsiveness. The very first impression that your user has of your software is the application launch. You want this to be quick, snappy, and responsive. As I mentioned earlier in this video, you want to assess what information is critical for launch during the design phase, and make sure you present this information to your user quickly. Remember, besides the data that is critical for launch, no other data should be loaded at this time. It can be loaded lazily later. I think that lots of developers try to optimize launch time, but another aspect of responsiveness that might not get quite as much attention is application quit time. I talked earlier in this video about the fact that pushing the home button or opening another application will terminate your application. This means that you want to be able to save the current state of your application when it quits in order to restore it later the next time it's launched. Doing this will ensure a seamless experience for your users. As with application launch, you should assess what information is critical to save on quit during the design phase of your application. The goal here is to write out just enough data to restore your application state the next time it is launched. So there's a really great reason that your application should be responsive on launch and quit, besides it being a great win for your users. And that's because it has to be responsive during launch and quit. Since there's no way to force quit an unresponsive application on iPhone, there are what we like to call watchdog timers in place. The duration of a watchdog timer is 20 seconds, and it applies to application launch and application quit, including the time it takes to write out data. If your application is unresponsive for more than 20 seconds, it will be automatically terminated by the system. So that's it for responsiveness. Now let's talk about power. Since network operations turn on certain components of iPhone hardware, they are quite power intensive. In fact, Transmitting data to a network is the single most power-intensive operation on iPhone, and receiving data is a close second. If you choose to transmit and receive data for the life of your application, this will have a notable effect on a user's battery life. The good news is, it's simple to minimize costly power operations in your code. Avoid pulling the network, and be sure to explicitly start and stop location services as needed when using a framework such as Core Location. So that's all I really have to say about power. Finally, let's talk a little bit about security. Protecting the integrity of the device and of the cell carrier's network is very important. So, each application on iPhone is put into a sandbox. This restricts the application to using only its own files and preferences and generally limits the system resources to which the application has access. It's important to remember that sandboxing only provides constraints on what an application can do in order to provide system security. While sandboxing can prevent an attacker from taking control of the device, it does not make your application immune to attack. Therefore, you should always engage in secure coding practices. If you're familiar with macOS 10, many of the security services that are available to you on the Mac are also available on iPhone, including keychain services, certificate, key, and trust services, and CMS services. So in summary, a great application for iPhone is designed for iPhone. You've thought through how users interact with their iPhone and what information is critical to the end goal of your application. Memory efficient. You've gone through the checklist that I've laid out here to reduce your application's memory footprint. Highly responsive. Your application launches, quits, and responds to low memory warnings in a timely fashion. Power conscious. You've minimized network activity in your application where possible. And lastly, secure. You've engaged in secure coding practices for your application while being aware of the constraints imposed by sandboxing. The definitive place to look for iPhone developer resources is developer.apple.com/iPhone. Here you'll find the orientation videos, technical documentation, and lots of sample code. Finally, feel free to contact me at vicky@apple.com with any questions you have about the material in this video. By now you have a list of best practices to incorporate into your iPhone application development. Make sure you take the time to write well-designed, efficient, and secure code. By following the guidelines in this video, you'll ensure that your users have a great experience with your application while they're on the move.